The idea that the Moon was once part of the Earth and later separated is linked to a prominent scientific theory known as the giant impact hypothesis. This theory suggests that the Moon formed billions of years ago when a Mars-sized body, often called Theia, collided with the early Earth. This impact was so immense that it caused a massive amount of debris from both the Earth and the impacting body to be ejected into space. Key stages of the Moon's formation. The giant impact, about 4.5 billion years ago, a large object, roughly the size of Mars, is believed to have struck the young Earth. This impact released tremendous energy, vaporizing a significant portion of the Earth's outer layers and causing the release of molten rock and gas. Formation of a debris disk. After the collision, the ejected material, including fragments of both Earth and Theia, formed a ring of debris around the Earth. Over time, due to gravity and other forces, this debris began to coalesce, gradually forming what would become the Moon. Moon's accretion, the debris slowly clumped together, forming a single, larger body, the Moon. This process is called accretion, where smaller particles and objects collide and stick together, gradually growing in size. Separation and orbit. Initially, the Moon was much closer to Earth. However, over billions of years, gravitational interactions between the Earth and the Moon caused the Moon to move away. Today, the Moon is about 375,000 kilometers, around 234,000 miles from Earth. The reason the Moon didn't fall back to Earth or drift further into space is because of a balance between two forces, Earth's gravitational pull and the Moon's orbital velocity. Earth's gravity continues to pull the Moon towards it, but the Moon's velocity allows it to maintain a stable orbit like a satellite. Why did Earth's gravity allow the Moon to drift away? Tidal forces. The Moon's gravity creates tides on Earth, and these tidal interactions are gradually slowing down Earth's rotation. At the same time, energy from this slowing rotation is transferred to the Moon, pushing it farther away. The Moon is currently drifting away from Earth at a rate of about 3.8 centimeters, 1.5 inches per year. Stability of the orbit. The Moon reached a point where the gravitational pull of Earth and the Moon's centrifugal force balanced, allowing it to remain in a stable orbit. This balance is why the Moon didn't continue drifting indefinitely but found a stable distance of around 375,000 kilometers. Why didn't the Earth's gravity keep the Moon closer? Earth's gravity was strong enough to keep the Moon in orbit, but not strong enough to pull it back to Earth because of the conservation of angular momentum. As Earth rotated, it transferred some of its angular momentum to the Moon, pushing it outward. The Moon reached a distance where its orbital speed and the gravitational pull of Earth were perfectly balanced, preventing it from falling back or escaping into space. Evidence supporting this theory. Similar composition. Rocks from the Moon, brought back by NASA's Apollo missions, have a similar composition to Earth's mantle. This supports the idea that the Moon was once part of the Earth. Isotopic similarity. Both the Earth and the Moon have nearly identical isotopic compositions, particularly in terms of oxygen isotopes. This further indicates that they originated from the same material.